Hey everyone, Math 103. This is the first of two videos for the graphing project. In this video, we're actually going to make the graph. And the second video, we're going to do some calculations and answer some questions. So we've got the beginnings of a graph here. And these two lines, they meet at a right angle. And this line is called an axis. And traditionally, this horizontal axis here, this is the x-axis. And this axis here is the y-axis. And you can think of these axes as being number lines. So as we go to the right, the numbers get larger and positive. As we go to the left, the numbers get smaller and possibly negative. And all along this axis represents the value of some sort of a quantity. And this represents the value of some other quantity. Now, as we're plotting points on the graph, these points are called sometimes coordinate pairs, sometimes ordered pairs. And so we're going to have two numbers in parentheses, and those two numbers are going to represent the position on the graph. So there's an ordered pair, 4 and 2. Now this first number, this represents the independent variable. And the independent variable is going to go on the horizontal axis. So 4 means we're going to move 4 places from 0. All right, 0 is right here at the origin. And the origin is where the two axes meet. So what we're going to do is we're going to take 4 steps from 0 on the horizontal axis. So 1, 2, 3, 4. All right, so there's the point represented by the 4. And now the 2, this represents moving here on the vertical axis, which is the dependent variable. So we're going to move 2 places up. So there's the point 4, 2 on the graph. And generally when we're graphing, I'm not going to write the coordinates, just graph the point. Now along the side is an axis scale. And these scales are really important when we're designing a graph because the design of the scale will determine how much of the graph we're going to use. So our goal is to use as much of the graph as possible. We may not fill up the whole thing, but what we don't want is to graph a bunch of points over here and then leave the rest of the graph empty. So by properly scaling the axes, we're going to avoid that. So up the top, you've got the maximum value on the axis. So the last, these are called tick marks. Tick marks are little lines that extend a little bit outside the graph. And so the last tick mark will have the maximum value. And the first mark here at the origin will have the minimum value. And now, on your graph, on the graph paper I handed out for the project, you've got lines that go all the way across. I wasn't going to draw all those in. But these are called divisions. And then the numbers on the outside here are called axis labels. And this is all on your handout. And then the difference between two values on your scale, that's the scale difference. And that's something we'll be calculating. So in graphing, the first thing we're going to do is determine which of the variables is the dependent variable and which is the independent variable. And this is absolutely essential to determine right away. So for the example, got the owner of a plant nursery is conducting an experiment to determine the effect of different amounts of fertilizer on plant growth. For a particular species of fern, the owner gave varying amounts of fertilizer to a collection of fern seedlings and recorded the average height of the plants after 1 month. So we've got fertilizer versus the height of the plant. So which one of these is going to be a dependent variable, which will be independent? So dependent and independent, it's cause and effect. The cause is the independent variable, and the effect is the dependent variable. Well, if we're varying the amount of fertilizer and seeing how high the plants grow, clearly the cause is going to be the amount of fertilizer we're putting on the plants. And the effect will be how high they grow. So that means the amount of fertilizer is the independent variable, and that is going to be graphed on the horizontal axis. The height of the plant is the dependent variable, and that will be graphed on the vertical axis. All right, so now we're going to scale the axes. And in order to scale these axes, first thing we need to determine is the maximum and minimum values on in each data set. So for the height, we have a minimum value of 3.1 for the height. The maximum value for the height is 12.0. And for fertilizer, we have a minimum value of 2 and a maximum value of 36. Once you find the maximum and minimum values, now we're going to find what's known as the range. The range is the difference between the maximum and the minimum. So as we've seen, difference is subtraction, so we're going to subtract the minimum value from the maximum value. So the height range, it's 12 minus 3.1. So the height range is 8.9. That will do the same thing for the fertilizer. So the range for the fertilizer is 34. Now we are going to divide by the number of squares on one side. So fertilizer is going on the horizontal axis. This is the independent variable. So we're going to count up how many squares we have on the graph paper. Okay. Well, we're all using the same graph paper, and I've already counted them up. So we've got 21 squares in the horizontal direction. So what we're going to do now is divide fertilizer range by the number of squares. So we take 34, divide by 21, and we get 1.619. So the difference then is 1.619. And if we want to make this the lowest value and the last tick the highest value, and we separate them all by 1.619, which spread out throughout the entire graph perfectly. However, we're going to get a really messy axis when we do that. So we're going to get a bunch of decimals, and then we're writing them horizontally. It's going to be really hard to write a bunch of decimals in here. So generally what's done is these will be rounded. Now we don't want to round them too much, because then we'll get a short graph. But if we round this up to 2, we'll be okay. We won't use the entire graph, but we'll use most of it. So we're going to round this up. to 2. So that's going to be the scale difference then between the tick marks on the horizontal graph. Now if that turns out to be too much rounding, you can go to like maybe 1.75. That way it's not too bad when you're writing these in. Or maybe 1 decimal would be better. You go to 1.7. But we always want to round up, never want to round down. So if we round down, then we're not, some of our data is going to fall off the graph if we round down. We'll go up to too small of a number here, and some of the data will be off the graph. Now for fertilizer, the lowest value is 2. At this point, you can make a decision whether or not to start with 0 or 2. Generally, we're going to start with the lowest value, but if we're right next to 0, we could start with 0. So in this case, I'm going to go ahead and start with 0. That's generally not recommended in general now. So I'm going to count by the scale difference, counting by 2 all the way up. All right, so that fills up our graph, going all the way up to 42 there. Now for the vertical scale difference, we've got a height range of 8.9. So we're going to do 8.9, and then we're going to divide by the number of squares in the vertical direction, and that is 14. So 8.9 divided by 14. So we get 0.6357. I'm going to go ahead and round that up to 1, nice round number. So we get a nice looking graph here. Lowest value is 3.1. So we could start here at 3. But since we're so close to 0, I'm going to go ahead and make it 0. If you're not close to 0, don't make this lowest value 0. So I've got the numbers on the axes, but the axes are not done. We're going to come back to that in step 4. Okay, now we're going to go ahead and plot the points. And these don't have to be exact, but they should be close. So the independent variable here is fertilizer. So we're going to fertilizer of 2, height 4.5. I get it right above the 2. And put a nice large dark dot there. Make sure you can see those dots. Second point, 4 and 6.3. Then we got 6 and 8.1. 8 and 8.9. And we're going across for the fertilizer and then straight up for the height of the plant. You got 10 and 10.5, so across 10, up 10.5. 12 and 10.7. 14 and 11.2, 16 and 11.6, 18 and 12, 20 and 11.9, 22 and 11.2, 24 and 10.5, 26 and 10.3, 28 and 9.3, 30 and 7.9, 32 and 6.3, 34 and 4.6, and 36 and 3.1. I was able to get pretty close with those. You'll be able to get a lot closer when you've got those guiding divisions going across. And do not draw lines or curves or connect the dots or anything like that. All right, now we're going to create axis labels and an informative title. So the title has to include both variables. Don't include the units in the title. That's a little bit too much detail. So we want to get the idea across of what we're doing here. It's fertilizer and fern height. So I've got some examples here. Fertilizer and fern growth, fertilizing growing ferns, the effects of fertilizer on fern growth, how fern growth is affected by fertilizer, relationship between fertilizer and plant growth. So things like that. So you got the three key pieces of information in there. We're talking about fertilizer, ferns, and growth. So there's a title, and now we want to do the axis labels. Now the axis labels, we need a little bit more detail in these. So we're going to include units. So we're measuring plant height here, or fern height, you can call it either way. And now these can be written, you can either write them with numbers that are vertical, or letters that are vertical and go down, or you can just take your text and tilt it on its side. It's generally done this way. Most graphs are just text tilted on its side. Okay, so we got fern height, or it could be plant height. And then the units in parentheses with a abbreviation, inches. All right, now we got fertilizer, and the fertilizer is measured in milliliters. It's liquid fertilizer. So for that axis label, we have amount of fertilizer, in parentheses, ml for milliliters. All right, so that's it for the graph. Just make sure you scale your axes properly using these calculations. When you're rounding, generally round up to the next whole number, unless that creates problems and we miss most of the graph. As you can see, we round up to the next whole number on these and end up using most of the graph this way and most of the graph this way, and that's what you want that to look like. All right, that's it for the first video. The next video, we'll be doing some calculations and answering some questions.